Starting with this video, we'll talk about information visualization, or InfoVis for short, and discuss how it helps with data analytics. First, we'll take a quick look at what it is, understand why it's important, and how it's related to humans' visual perception and the Gestalt psychology. Then finally, we'll go through the fundamentals in designing effective charts and how to use colors effectively in your visualization. Let's start and look at what InfoVis is and why it is important. The materials in this lecture is based in part from the materials by Professor Chet Stoper, who is now an assistant professor at Southwestern University. Chet graduated from Georgia Tech from his CS PhD program, and he was co-advised by me and also Professor John Stasko. So what is information visualization? The use of computer-supported interactive visual representation of abstract idea to amplify cognition is probably the most well-known definition of information visualization. And it can help with communication and exploratory data analysis. So if EDA or exploratory data analysis is new to you, then you will find that visualizations are very powerful tool to help people explore and make sense of information. But first, we'll start with the more common use, which is communication, as in how do you relate information to people through visualization. And a good way to understand why visualization is important for communication, I think the best way is to understand what would happen when something goes wrong. We'll use an example from the book Visual Explanations by Edward Tufte. If you haven't heard of Edward Tufte yet, he's a very famous researcher and a pioneer in the field of data visualization. And he's also a professor of computer science at Yale University. You'll hear about his name a lot as we go through the visualization materials in this video. The example we're going to look at is a Space Shuttle Challenger incident. You may remember that it was a tragedy that happens in 1986, January 28th, in a very cold morning with only 31 Fahrenheit. What happened was that the shuttle exploded in midair shortly after launch. After the incident, very quickly, people discovered that the problem was due to a rubber O-ring, which is in the middle of the rocket. Because the temperature was very cold, it becomes very rigid, and it breaks, and then the leak fuel goes out of the rocket, and that caused the explosion. And in fact, this was highlighted in a video by Richard Feynman, who's a physics Nobel laureate. And in front of Congress, he explained how the rubber became so rigid in cold temperature. So if you haven't watched this experiment, highly encourage you to go to the YouTube video link there and take a look. So how did this happen, and how is it related to visualization? In fact, the day before the tragedy, engineers at Morton Thiokol, which is the rocket maker, presented on the day before and recommended to NASA not to launch the shuttle on the next day. In one of their slides, there's a specific recommendation that says the O-ring temperature, which is the rubber ring and the rocket, it should be higher than 53 Fahrenheit at launch. And if it's lower, then it's probably not a good situation. And they even have a slide that shows the damage that was recorded in previous experiments. And all these rockets showing here on the screen is looking at different temperatures, as you can see the numbers at the top of the rockets. And also, what are the damages that are recorded? For example, on the first row, you will see that the second set of rockets, there's some damage towards the lower right of the rocket on the right. So what it's showing here is that at various temperatures, there are actually certain damages happening to the rocket from here and there. And generally, it seems like that for lower temperature, there are more damages. However, in this chart, it's actually not very easy to see. For example, here you will see there are a lot of rockets. But as you know, a space shuttle has two rockets, right? So that means that left and right. And here it's represented as A and B. But at a higher level or at a glance, you will probably see, wow, there's just so many of them. And so how should I interpret? How should I group these rockets together? And how do I really correlate the temperature and the damage that's recorded? So whatever Tufte is arguing is that this is probably not a very good visualization, and in partly contribute to the incidents, because this was not very convincing, and NASA decided still to launch a shuttle. And what he did is he came up with alternative design. And first of all, he will say that probably it's more effective to show all the rockets on one line, horizontal line, instead of having two columns. Because having two columns, then you also need to think about vertically What does it mean? What does the layout mean? Even more, he's saying that we should probably use something that looks like a histogram, where we have a horizontal axis, which is the temperature, and then put all the experiments, each one as one set of 2 rockets, in this histogram. So this is very familiar to what you would learn about in elementary school, right? Where each pair of picture denotes an experiment that you have run. So just by putting all the data in this histogram format, you can already see that most of the experiments were run towards the higher temperature scale, so around 70. While for the temperature at 30, there's only 1 launch. So that means we don't really have that much data to really look at what would happen during the very cold day, like the day of launch. And also visually, now you can see that when the temperature is high, let's say about 70, there's generally not really that much damage. But as they go lower, starting around 70 and below, then we see a lot more highlighted area or opaque area on the rocket, indicating damage. And Edward Tufte says that, well, probably that's not even clear enough. So what about the extent of damage, as in how severe it was the damage? In that histogram, we don't really see it. So what he's suggesting is that maybe we should have a damage index, which encodes the severity, which is shown on the last column here, damage index column. Higher the number, the more severe. So by turning all those picture or visual information into damage index, now we can see that for lower temperature, like the first row, 53 degrees, then the damage can be really high. So that was in picture form. Edward Tufte also tried that by using a scatter plot, we can probably even see trends, which may not be covered in the table format. So here we have 2 axes. The vertical axis is the damage index, which we explained previously. And the horizontal axis is the temperature. So each dot here is 1 experiment. So as you can probably already see, there's actually an upward trend going from the lower right. And then as the temperature goes lower, which is to your left, we can see that the damage tends to increase. Actually, it's a slope going up pretty rapidly. And if you believe in this trend, what would you expect to see at a very low temperature, which is towards the lower left of the screen? Likely it's not a very good idea to launch because, well, if this curve is true, then the damage index is going to be really high. So the example that we just saw was for the Space Shuttle Challenger, where communication could have played a very important role in the incidents. So in other words, communication is extremely important, and visualization can make or break your presentation. To convince yourself more, I highly recommend that you watch the TED Talk videos by Professor Hans Rosling, where he turns everyday statistics into some of the most exciting, most compelling presentation you may have ever seen. So visualization can help with communication. And other lesser-known use of visualization is that it can also help with exploratory data analysis, or EDA. As the name suggests, exploratory data analysis, or EDA, means to explore data. As in, if you're not really familiar with the data, then how to make sense of it, how to better understand it, or get yourselves more familiar with the data set. A lot of people would argue that exploratory data analysis is probably not really important because, well, you collected the data set, then you probably know very well about what's in it. But is that always the case? And when do you need to explore data, and why do you need to do it? So to motivate the use of EDA, I will start with a quote, which says there are 3 kinds of lies: damned lies, and statistics. What it's saying is that if you don't visualize the data or don't really see what's in the data and rely on statistics or numbers alone, you may not get the full picture, and sometimes even get a very misleading picture. So here's the mystery data set. And I want you to guess what it really represents. So in this data set, we have 2 variables, x and y. And in this table, I will tell you about some statistics in the data set. So I'll say the mean of the x variable is 9, the variance is 11, the mean of y is 7.5, and variance is 4.12. And I will even tell you the correlation is 0.8. And even better, I would do the regression for you. So I'll fit a line through the data, and I'll say the relation between y and x is y equals 3 plus 0.5 of x. So what would this data set look like? Right, would it look like this? So here I'm showing you a scatter plot, plotting x and y. And You see the line there, which is a regression line, and it's cutting through the data. That looks all right, right? So I guess probably most people would agree. But now what about this one? So it's a little more curvy, and you may be surprised that it actually gives the exact same identical numbers that you already saw in the table. In this case, you may say, OK, maybe I would say that the blue line, maybe I should tilt up a little bit. But if you say it's the same statistics, OK, I agree with you, and that's probably OK. What about this third case, where we have one outlier, one point really sticking out to the top? While the remaining points, they are more or less lining up on a line. And just visually, you may already see that, well, probably want to ignore the data point up there, right? And so that my blue line can really cut through the middle of all the other points. But surprisingly, you will also find that it gives the same identical statistics in the table. If that's not extreme enough, that's the fourth case. This also gives you the same statistics. And in this case, we have one point far to the top right, and then all the other points line up vertically. And unfortunately, this also gives you the same identical statistics. So these four charts actually is from the famous Anscombe's quartet. And this is a perfect illustration to show you that if you just look at the numbers, which are the statistics that we saw in the table, they not necessarily tell you the full picture or the distribution of the data. By visualizing the data, we'll see that, well, you can actually have many, many possibilities that give you the same thing. So this really motivates you why you want to do visualization, because it really helps you explore and make sense of the data. And if someone just say, here's a data set, just trust us, you probably want to do a sanity check. So sanity checking models is a really powerful use of visualization. And also, you will know that it's also really good at detecting outliers, because people can really quickly pick out things that are sticking out, such as the lower two cases, or third case and fourth cases, where there are the data points that are really to the top right or at the very top. In this video, we look at what InfoVis is and why it is important. We saw that visualization can play critical roles in communication and exploratory data analysis. And not doing it correctly can have really bad consequences.